simplify complex fractions. So first of all, the definition of a complex fraction is it is a rational expression or expressions that are divided by one or more other rational expressions. So here's a very simple example of a complex fraction. This is just one rational expression over another rational expression. And then technically these aren't really rational expressions because they don't have variables in their denominators. But anyway, this is just a simple example of it, okay? Usually, you'll see some more complicated examples. We've got like x squared over 16 plus x over x minus 2 or something in the top, okay? It can have any variety of pieces, number of pieces. So here is how we're going to tackle these. This is what I think is the easiest way to do it. So we're going to factor everything that we can possibly factor and find the LCD. We're going to multiply each expression by the LCD, only the numerators though. Okay? We're not trying to get a common denominator like we were with the adding and subtracting, where we were trying to get the same denominator. Here, we're trying to eliminate the little denominators, is what we're trying to do. We are trying to eliminate the little, I call them little denominators. 16 and 4 would be the little denominators. X plus 1 over 4 is the main denominator. Okay? And then we want to cancel common factors and then simplify as much as we possibly can. Okay, so that's kind of the strategy that we're going to take to do this. So for this one, the LCD would be 16. So we would go through and we would multiply just the numerators by 16. Okay, we're not actually multiplying it out. We're going to end up canceling. In this case, we cancel the 16ths. So we've just got x squared. In this case, 16 over 4 leaves us with 4. So we've got 4 times x plus 1. And that's as far as we can go with this one. There's not a whole lot more simplifying to be done in this case because it is such a simple case. Now, technically, with this one, it's just a fraction of a fraction. We could have just flipped and multiplied and canceled. We would have gotten to the same result. I was just trying to start with a simple example of using this technique. Okay? So, let's look at one that's got a little bit more to it. Okay, here we go. X plus 3 is the numerator. X plus 3 over x minus 4x over x plus 3 is our big denominator. And before y'all ask, no, we cannot cancel x plus 3. Because there's a minus sign. Sorry, you're trying to be smart over here. I just wanted to see my reaction. There's a minus sign right there. You cannot cancel those x plus 3s, and you cannot cancel the x plus 3 in the numerator with the x plus 3 that's right below it. Okay? We can't. Because of the minus. Y'all are going to remember this. If there's a minus sign in there, you cannot cancel anything. All right. So, LCD. We got x. We got x plus 3. Okay? LCD is x and x plus 3. Because here's the x plus 3. All right, so we are going to go through and we are going to multiply each rational expression by our LCD. So the top gets multiplied by x and x plus 3. This gets multiplied by x and x plus 3. I'm just fitting it in however I can. This gets multiplied by x and x plus 3. We're not actually multiplying out yet. We need to cancel anything that we can cancel. So we can't cancel anything in the numerator. because it didn't have a denominator. It didn't have a little denominator up there in the numerator. Okay? So, in the denominator, we can cancel the x. Okay, so let me go ahead and start my next line, what I've got left. Nothing changed in the numerator because we didn't have a denominator. In the denominator, the x cancels, so we've got x plus 3 times x plus 3. Don't lose your minus sign. Okay. In the second part in the denominator, the x plus 3 cancels, so we've got 4x times x. So we have eliminated all the little denominators. Before we can simplify, we've got to simplify that denominator. We cannot cancel those x plus 3's because of the minus sign. So leave the numerator in factored form. Leave the numerator in factored form because we're going to try and see if we can get the denominator in a factored form that will allow us to simplify. But we have to multiply it out first. So x plus 3 times x plus 3 is x squared plus 6x plus 9. And we've got minus 4x squared. Leave the numerator in factored form. X times x plus 3 times x plus 3. Combine the x squared and the minus 4x squared. Negative 3x squared plus 6x plus 9. What can we factor in the denominator? We can factor out not just 3, negative 3, x squared minus 2x minus 3. We're almost there. That is x minus 3 times x plus 1. Prime example of a situation where you must be careful with your signs. It's negative 3 plus 1 that multiplies to give you negative 3 and adds to give you negative 2. So nothing cancels. We have it in fully factored form where we could cancel. We can finally cancel right here if there were something in common, but there's not. So this is it. Leave it in this form. Okay? All right. Oh, hello. It's time to go.